Okay, good morning first grade and first grade parents. This is the video for April 7th, and my student teacher, Ms. Smith, did the ELA video. So I am going to do the math video. And by now, I have the packet too, because I've been recording these videos a few days early. So I want to show you what you're working on in the packet today. And that is missing numbers. Now, like we discussed last week, your packet is asking you to do 10 frames. That is certainly a way to find the answer, but it's not the only way. So if you have at home, if you have a number line, your child can do this on a number line. If you have a hundreds chart, they can use a hundreds chart. If you just have something they can draw on, they can make a model with circles. If you have a manipulative, a thing that they can count, they can use that. The big idea for today's lesson, and really the hardest part, is understanding the part-part-whole relationship. So that's really what I'm going to focus on today. Now, you'll notice, and I know looking at this from when we grew up, we're thinking, oh, we never had our problem set up this way. That's true. We typically had our problem set up like this one, where the answer, if we want to call it that, was on one side, and the expression part was over here. But the issue with that is that when kids get into algebra in 5th grade, middle school, things like that, if they have only ever seen this single number, the answer on one side, it doesn't really prepare them for solving equations. So the reason that the problems are set up like this is to lead into that algebra component and get them used to the idea that equal does not mean the answer. Equal means whatever the value of one side is, we need to make the other side have the same value. So when we're looking at this from a first grade idea, a lot of times I see kids will look at the two numbers and just automatically want to add them, but that's not always the case. What they really need to get out of this is understanding what they're really finding. So for that, I'm going to use two strategies that we do in the room. We're going to use a part-part-whole box and a number bond. Now, sometimes you will see these flip-flopped, like you may see the bigger box up here, or you may see this reversed. Really, kids should understand that either way. Another thing that I have found helpful when doing this is if you relate it to a story. Sometimes you can ask your kids to tell you a story with that. So when I look at 15 minus blank equals 7, I may make up a story for that. And I might say that I had 15 brownies. I always talk about food because kids love food, and so do I. So I might say I have 15 brownies, and that minus sign tells me that I'm taking part of it away or that some were different. So I'm going to say I had 15 brownies. I gave some to my kids. Now that some is our missing addend. And now I have 7 left. In my classroom, we also do this. I will say I had 15 brownies. I gave some, and then I'll tell the kids this is our missing number. We don't know what it is yet. I gave some to my kids, and I have 7 left. So the question that I'm finding here is not how many did I start with. It's not how many did I have left. It's the part that I gave to my kids. So looking at it in our part-part-whole box, 15 is my total. 15 is my whole number. So that goes in the big chunk of my box, or the big chunk of my number bond. 7 is the part I had left over. So what I'm finding is the missing addend. And something that I'll ask the kids in the room is, the number that I'm looking for, is that going to be smaller than the biggest number that we know, or is it going to be bigger than the biggest number that we know? Now, some kids will want to add these, and they may punch and count 15, 16, 17, 18, 19, 20, 21, 22, and they might get 22. Now, if they get that and they fill it in for all this, this is what I'm going to ask them. Does it make sense that I start with 15 brownies and I give away 22? And then in the room they all go, no, that doesn't make sense, because what I did here is I added and I got a bigger missing add-in, and that doesn't make sense. So in this model, or in this problem, we're looking for a smaller number than 15. So I'm going to show this to you on with a model today. So I am going to model 15 circles. Now your kids are going to be a little bit slower, and we want them to double check, of course. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now in this problem, I know that I have 7 left. So this is what I'm going to do. I'm going to color in the 7 that I have left. I'm going to just separate that. So this is what I have left, which means this is the part that I gave away. And then I just have them counted. 5, 6, 7, 8. So in this problem, the missing number is 8. All right, we were finding a smaller number. All right, let's do another example for our next problem. Now this problem, and I tried to give you 4 separate kinds of problems so that you could see all of them. And of course, if you're thinking right now, well, I'm fine with this, and you can quit watching, but if you want to see them all, that's fine also. All right, so in this problem, we have blank minus 4 equals 6. So a number or a problem that I can make up a story to go with this is, maybe we'll talk about animals, all right? So I might tell this child that this is the beginning of the problem. So let's talk about dogs. In this one, I would say there were some dogs at the park. Okay, some is the number we don't know. There are some dogs at the park. 4 of them chased the mailman, and then there were 6 left. So in this problem with our moving model, it would look like this. There were some animals at the park. Some is our total. You see the difference? There are some animals at the park. 4 of them ran away to chase a dog, and there were 6 left. So did you notice when I separated my hands, the 2 numbers that we know are the smaller 2 numbers. So in this model, 4 dogs ran away, 6 stayed. 4 dogs ran away, 6 stayed. So in this number, we are looking for a number bigger than or smaller than the biggest number we see. And that one should be a bigger number because we want the total that we started with. So this one, you may have some kids that when they figure this out, they just say, oh, 4 plus 6 is 10. Great, they know it. Some may need to do that punch and count. So they may punch 6, 7, 8, 9, 10. Maybe they'll use a number line. And if they do that, I don't have a number line right here, but they would start at 6 and jump 1, 2, 3, 4. Cool thing about number lines, you can always make your own number line. So count the hops, 1, 2, 3, 4, and just count on. 7, 8, 9, 10. You can model it, of course. You can show, here's the 4 dogs that left, plus the 6 dogs that stayed. And either way that we do it, we get a total of 10. And 10 was our beginning total, which is also our whole number. So the difference here, sometimes we're finding a missing addend, like this problem. Sometimes we're finding a missing total. And that's the toughest part really for first graders to understand. So let's look at this one. Here we have 5 equals blank minus 9. Now, a lot of students still get a little bit confused on a problem like this when this is set up this way. So one thing that I do in the room is I will look at that equal sign and I will box up whatever's on this side and I will box up whatever's on that side as 2 separate amounts. But remember, that equal sign tells us we want them to be the same. So when I look at this, I am thinking blank minus 9 equals 5. I'm just going to say it and flip it. That's fine. Or you can say 5 equals blank minus 9. Well, when we look at this, we're looking for the same thing we looked for here. We're looking for the total. So a problem I could say with this is I had some starburst. There's my sum. I had some starburst. 9 of them were yellow. The rest, which is 5 were blue. So listen to this again. I had some starburst, 9 were yellow, the rest were blue. Well, in this problem, it was a part. We separated them. So if we're thinking of that, we're going to say 5 of my starbursts were blue and 9 were yellow. And so for this problem, we're really finding our total of all the starbursts. So again, they can then use the number chart, they can use a number line, they can make a model, they may just know the facts. They may make a 10 on this problem. Maybe they will use their 10 frame and fill it in. So if they're using a 10 frame on this, they're going to show 9. I'm going to do this in a different color. And then they're going to add 5 more. 1, 2, 3, 4, 5. And then they're going to quickly see that it's a 10 and 4 more. And a 10 and 4 more is 14. So in this problem, we are missing the whole number, which is 14. All right, last one for today. All right, in this problem, we have 4 equals 12 minus something. My little ones are up right now. All right, so in this problem, we have 4 equals 12 minus something. Now again, if they're having problems because this is reversed, which really it's not, but it's not the way that we typically see it, you can box up this side and box up that side. So in this problem, we are looking for 12 minus something equals 4, or 4 equals 12 minus something. So let's go back to food for this one. So let's say that I made 12 total cupcakes. Where did I just say? 12 total cupcakes. Some of them were chocolate and 4 were vanilla. So listen again. I made 12 total cupcakes. Some of them were chocolate. See, that's a small part. And 4 of them were vanilla. So when I am showing this on my part whole, I know the vanilla part. I don't know the chocolate part. So 4 are vanilla, I don't know the chocolate. 4 are vanilla, don't know the chocolate. 12 is the total number of cupcakes I made. So in this problem, am I looking for a number bigger than the biggest number I see, or smaller than the biggest number I see? And this time it's going to be smaller, because we're taking that group of 12 and we're splitting them. So for this one, again, you can use any of those strategies. I am going to use a model for this one. Okay, so there's my 12, a 10 and 2. And I am going to show 4 are vanilla. So I am separating 4 of them. And then I'm just going to count what's left over, because the leftover part is chocolate. And sometimes in the room I will label them. This is the vanilla part. This is the chocolate part. So 1, 2, 3, 4, 5, 6, 7, 8. 8 are chocolate. And in this problem, we were looking for a small part. So that's our math for today. Again, contact your child's teacher if they're having, any particular issues, but I just showed you a lot of ways to do it. So we did it with movement. We did it with 4 different kinds of models. Now, you don't have to do every single model. And then we did it with a lot of different ways to solve the problem. All right, have a good day. Bye.